Hi children, in this video I am going to explain Hund's rule. This is the one of the important rule while we are assigning the electrons or distributing the electrons to the shells and subshells. Okay children, this is one of the most important topic for public examination point of view in your 10th class. What is the Hund's rule and how we can identify whether the given configuration is right or wrong? Let's go for that. Children, according to the Hund's rule, while distributing the electrons into the subshells into the degenerate orbitals, every degenerate orbital must be every degenerate orbital must be occupied by with one electron or single electrons. After filling the all degenerate orbitals, then only pair of electrons should be takes place. That is called Hund's rule. According to the Hund's rule, while we are distributing the electrons into the subshells, first every degenerate orbital must be occupied by the one electron single. After completion of all degenerate orbitals, only pair of electrons takes place. That should be called Hund's rule. After giving one example, you may come to the understand very easily. Okay children, in examination point of view, they will ask like this. Here I am going to take some fluorine. Atomic number is 9. Atomic number is 9. So 1s2 configuration is 1s2, 2s2, 2p, 5. Fluorine is the atomic number 9. 9 electrons are there. The configuration should be like this: 1s2, 2s2, 2p, 5. So children, S consists of only one degenerate orbital, P consists of 3 degenerate orbitals, and D consists of 5 degenerate orbitals, and F orbital consists of 7 degenerate orbitals. Here S consists of 1 degenerate orbital, P consists of 3 degenerate orbitals, and D 5 degenerate orbitals, and F is 7. And here every degenerate orbital consists of 2 electrons. That's why 1 into 2, here 2 electrons are there. And now in this case 3 into 2, 6 electrons are there. Here 5 into 2, 10 electrons, and 7 into 2, 14 electrons. Clear children? I already explained number of electrons in orbitals and how many number of electrons in a shell and how many electrons in a subshells and how many number of electrons in degenerate orbitals. I clearly explained previous videos. So that's why if you have no idea about all these things, simply you go to the previous videos, just check it once. Okay children, just in this video, just I am telling you clearly, S orbital consists of 2 electrons, P orbital consists of 6 electrons, and D orbital consists of 10 electrons, and F orbital consists of 14 electrons. 14 electrons. So you simply have to remember that. That's why here 1s2, 2s2, 2p5. Clear? Here in examination point of view, they given like this: 1s2 and distribution of electrons like this. This is 1s and this is 2s. And P consists of how many there? 3 degenerate orbitals. 1, 2, 3. Clear? So they given like this. So here it was given like this. Here 2 plus 2, 4, 4 plus 3, what we have? 2 plus 2, 4, 4 plus 5, 9, 1, 2, 4, 5, 6, 8. So now here how many there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 electrons are there. So here generally this is called generally 2px, 2py, 2pz. So he was given that is the distribution of electrons. So he was asked in the question whether this is the right or wrong. correct or not, justify your answer. Ask like that. Then what we have to say, this is right or wrong. So here this is the configuration is wrong. Why it is wrong? Just we go for explanation. Why it is wrong? Because here in case of P, how many there? S, 3, 1, 2, 3. So here how many there? Here 5 electrons are there. 5 electrons and 3 degenerate orbitals. This is 2px, 2py and 2pz. Clear? These 5 electrons must be distributed according to Hund's rule. Every degenerate orbital must be filled with 1 electron each degenerate orbitals. That is the first, that's the thing. According to Hund's rule, every degenerate orbital must be filled with 1 electron each. After, how many are here? 5 there. So in that 5, 3 distributed. 2px1, 2py1, 2pz1. Now here these electrons must be, how many left here? 2 remaining. These 2 are filled like this. That should be pairing of electrons should be starts from again 2px, 2py, 2pz. In these 3, 2px is the less one. That's why first here pair of electrons should be takes place in 2px, and now here 2py. And now it is balanced. 2 plus 2, 4, 4 plus 1, 5. That's why it is wrong. That's why it is wrong. The given configuration is wrong because according to the Hund's rule, first every degenerate orbital should be given by like this 1 we have to fill. After that only pairing of electron takes place. In this case what you observe, first 2px is not filled. Without filling the 2px pairing, there is no pairing in 2px, but they paired in 2py, 2pz. That's the wrong. Clear, children? Okay, I will give one more example, children, here. Now here I will go for nitrogen. Atomic number is what? 7. Now configuration is what? 1s2, 2s2, 2p3. Clear? 1s2, 2s2, 2p3. This is the configuration of nitrogen. In examination point of view, maybe you written as like this. You written, or in question they give like this. Clear? 1s2, 2 electrons are there, 2s2 completed. Here mentioned like this. So 1s2, 2s2 like this. So now it is right or wrong? It is wrong, because according to Hund's rule we will go for like this. Clear? 1s2, 2s2 clear. Now we go for 1s2, 2s2 is clear. Next 2p3, 2p3. In p orbital how many there? 3 there. Then p consists of how many degenerate orbitals? 3 there. So first we have to give 1, 1, 1 each. After that only pairing should be takes place. But here in the given configuration this is the empty. That's why it is not follows the Hund's rule. According to Hund's rule, every degenerate orbital must be given by 1 electron each. After that only pairing of electron takes place. That's why here 1s2, 2s2 and what you wrote like this is the wrong. That's why it not obeys the Hund's rule. Clear? To correct that we have to write like this. How we can write this? According to Hund's rule, every degenerate orbital must be given by 1 each. Then only we will go for pairing of electrons. Clear? So without filling the third degenerate orbitals of p, pairing takes place. That's why it is wrong. Okay, children, in this way you have to understand the Hund's rule. According to the Hund's rule, when we go for degenerate orbitals, first every degenerate orbital must be filled with 1 electron each. After that only pairing of electrons should be takes place. Okay, children, I hope you understand. We will meet in the next video with some other interesting topic. Bye, take care.